Now it's time to bring up our panel. Our host for the panel is Hemal Shah from Broadcom. You're part of the panel. Okay.
Hello. Can you hear me? Okay. Good. All right. So thanks, everyone. This is our OvS Acceleration panel. We have heard a lot of OvS offload talk during this conference, and they're all around the benefits, the framework, and other. I thought that we'll get a panel of diversified set of people so that we can go over where we are in terms of OvS Acceleration. And I've been working on this for quite a long time, not just OvS, but vSwitch acceleration, and with offload, there are challenges. So this panel is basically to entertain that kind of discussion. In terms of panel format, it's pretty flexible. What we'll have is, we'll have each panelist spend about 2 minutes to go over, this is the guideline. We'll talk about, they'll introduce themselves, what their involvement in OvS, the importance, and where we are today, and then what are the challenges. And I'll kick it off and hand it to each panelist. Once we have finished that, I put in some sample questions here for the audience, but we don't have to stick to it. We'll just open it up and want to have live discussion. So that's the panel format. So with that, let me kick off. I am Hemal, system architect at Broadcom, working on the Ethernet controller for a long time, all the way from 1 gig to 100 gig. And OvS, we have supported OvS TC-based, RT flow-based solution in our products for several generations now. As we see 100 gig SRIOV getting deployed, the need for offload and performance benefit that offload provides is increasing. And so there is clearly a case to be made here. If you want to achieve like 100 million packet per second, achieve line rate throughput with OvS, you will need some of those kind of offload benefit. So that definitely makes case for that OvS offload acceleration. That being said, where we are today, if you really look at it, primarily we have focused on the data plane. And we have done decent job at creating all this framework where we have all those data plane functions offloaded. Where I see the problem is some of the control plane and management plane. And we had a talk yesterday where I talked about some of the discovery offload piece missing, the way the representatives are handled are not a standard way. Things like error reporting, integration with OpenStack oven. So there are a lot of those challenges. What this does is it makes life really difficult to deploy this as a solution. So with that, even if it pains me a lot to have all this hardware capability, but I'm going to say that we are not there yet. We're actually at the beginning. And one of the things I feel that hardware vendors like us, Mellanox, Intel, we have been working on this offload for a while. While the software features and evolvement of OvS has gone on, what we need a much tighter working between the software side and the hardware vendor. I believe there is a gap in there. And that is kind of because we are coming bottom up, features being developed top down. And then offload is not always the thought when you are developing a new feature saying, how will this integrate with hardware? So that's I think, an area where I would suggest we should really focus on going forward. With that being said, what I'm going to do is go by the order we had on the start with Ian, and then we'll go in the company alphabetical order. So let me give it to my next speaker here.
Thanks. I suppose people don't know me from yesterday. My name's Ian Stokes. I'm a network software engineer for Intel, and I'm also a maintainer for the Open vSwitch project, specifically around user space and DPDK. I suppose, yeah, the importance of the OvS acceleration and offloading, it's quite clear. I mean, from the presentations we've seen yesterday and today, to hit these kind of high line rates, it's somewhere where we definitely need to go. I guess from my point of view, that would be one aspect. If I take a narrower view around OvS as a project itself, I look at it as the OvS kernel side versus the OvS user space side, which typically tracks in DPDK. I also think there's an issue there with feature parity, and it's kind of important to keep an even keel between both approaches. So that's kind of maybe a little narrower view that it can affect my day-to-day job. But that's why I think it's important as work that should continue on in the user space side, just to keep that even keel. With regards to current status, I still think it's early days. I was involved kind of reviewing and working with Mellanox for the initial partial offload maybe a year, 2 years ago at this point. And it's still an experimental feature. We've now moved to DPDK 1911, which I believe should help in enabling a lot more around RT flow. But I'm also happy to see kind of a lot more vendors standing up, and with Broadcom and Intel now, there seems to be more hardware vendors finally coming into the picture and pushing it, so it's not just all on one vendor trying to drive, which has, I think, been the case to date. Gaps and challenges, I think it's fair to say, it's very much still the early days. One aspect I'd like to call out, and you've just touched on it, would be, we are a virtual switch at the end of the day. We're software based. It's a question that's kind of come across to me, community calls, hey, what if we have this special feature in hardware that we can enable, but it's not after being implemented in software? Is that a blocker? Well, as a virtual switch, I would almost say yes. And if I take off my vendor hat and put on the maintainer hat, I want to see the software there, to be honest. But that's kind of tying back into, you said, a tighter coupling as regards enabling these features, I think, is key. And even moving away from the, let's say, flow offload aspect, we still have issues in DPDK, at least, around just other offloads such as TSO, which are taken for granted in the kernel aspect. But that's work that we're still catching up on today, which again affects NIC vendors again. So again, I think a tighter coupling and approach there should be good to kind of kick off there. So yep, that's my views. Thank you.
Okay. So my name is Olga Shah, and I'm a senior director in R&D group in Mellanox. I'm managing DPDK and hardware offload group, user space and kernel. So my group is involved deeply in OvS offload in DPDK and kernel, and also, of course, in infrastructure. So also in DPDK RT flow, of course. So the importance, I think we all know, it's we discuss it a lot. We do see that with NICs like 25 gig and above, we do need a line rate, and we can achieve it only with hardware offloads. Also, the scalability with a number of flows. We know that our customers needs millions of flows, so it can be done only with hardware. And of course, we want to save CPU. So this is mainly what hardware offload needs for. If we are there, I think we are there. I think that the kernel, OvS kernel, is mature enough. We do need to complete the connection tracking. I agree, but we have a lot of customers that's already in production with the OvS offloads, and even it was discussed in months ago in Shanghai OpenStack Summit. We have JD.com and ByteDance that are working with OvS offloads with Mellanox. So DPDK, I do think that RT flow in 1911 is complete from a Mellanox point of view. Maybe something is, I understand that something is missing from for other vendors. We need to work together to improve it, of course. We do have, we continue to work also on DPDK offload, OvS DPDK offloads, and as Oz mentioned, we already have patches for the VIX and encapsulation, and we are working on connection tracking. So I think we'll, for DPDK, we have more work to do, of course, but we definitely there. It doesn't mean that we don't have work. That's why I have a job. And we are missing, I think that even in the software, like I mentioned, where we discussed with Simon this morning that IPSec, for example, is missing in OvS kernel and OvS DPDK, of course. And we want to also to offload a quality of service, metering and shaping. This is something also in our roadmap.
Hello, I'm Simon Holman. I work with Metronome. I'm the architect of the OvS offload product for Metronome, and I also coordinate open source activities there. I've been working on OvS for some time, and Metronome and myself, we've been working on offload for some time. I think to echo some of the comments that have been made already, I mean, we have come a long way in the 5 or so years since I've been directly involved in hardware offloads. We have an upstream solution for DPDK to some extent, for the kernel for a greater extent. It's not complete, but I agree that we have come a long way, and once contract is complete, things are looking fairly fully featured on the kernel side. Of course, there's more work in terms of QoS and other encapsulation formats and security crypto aspects. There's always more things to be done. I think one thing that is interesting is that as these things have been added, of course, OvS is a software project, and it came first, and the hardware offloads came later. And so the hardware offloads have always tried to fit in sort of at the lowest level, which makes sense. But I think as new features are added, it does make some sense to take a more holistic approach and take a look at when we're adding a new feature at the software level, at the highest level, what is the right approach to this problem that doesn't overburden particular levels of the stack. I think I don't have an alternate design proposal, but the complexity of the contract is quite significant, and the sort of the hoops we have to jump around on the hardware side are also significant. I'm not saying it should be redesigned, but I'm saying it's an example of where perhaps a different approach may have led to a cleaner implementation at various levels of the stack. And just in closing, I of course agree that as we increase the line rate, of course, hardware offload becomes important. And in general, Metronome believes very strongly that as the network usage increases, then co-processors are really the only viable way to cope with users' needs. Thank you.
Thank you, guys. So first of all, thank you, Hemal, for putting this panel together and for not making us make slides. So thank you. Awesome. So with that said, my name is Raschid Khan. I work at Red Hat, as you might know. I'm just here for my good looks and charm. And instead of doing hardware offloading, now I'm thinking of event planning. I think there's more money in event planning than that. But honestly, we've been working, first of all the hardware vendors, I really appreciate all the work and patience that everybody has put in to get us where we are at. We have never been closer than we are at this point, particularly Mellanox, Intel, Broadcom, Metronome, everybody, Cavium, now Marvell, everybody has really been trying. If it was easy, it would have been solved by now. It isn't easy. It is complicated. What makes it even more complicated is that the chip tape out is 18 months before the chip is available in hand. So a lot of software folks might not recognize this, but the chip planners have to decide what to put in and what to take out 18 months, maybe 2 years in advance. And then during that time, they have to manipulate it, etc. But once the tape out has happened, nothing can be changed. It's now the chip is going to come back. You have to put it on a card. So software keeps changing while the tape outs are happening. So it's like 2 different trains, and we are trying to run from one train to another. So it is very complicated. The features are complicated. Connection tracking is there. So 3 years ago, when we started putting the first patches into OVS, some of our friends in OVS maintainership, let's call him Justin, was very reluctant. He's not in the room, so he's somewhere. So he was reluctant. Justin's right there. Dang it. So Justin was like, okay, Rashid, without connection tracking, it's going to be difficult. And he was right, and he is still right. And I said, Justin, let's do it. Rome wasn't built in a day. We'll get initial stuff in, and then we will add connection tracking. And that was about 2 to 3 years ago. And every time I look at him, I'm sort of embarrassed because I sort of said, hey, I'll work with everybody to get that in. It is difficult, and everybody has been trying. With connection tracking in, I think it's going to go leap forward. And but we appreciate everybody's work. Aaron is standing there. He runs the meeting for everybody to converge. So bottom line is we have never been closer, but it's still some mountain to climb.
Hi, my name is Ben. I've been working on OVS for a while. I'm a little worried that my role when it comes to acceleration is kind of to be the wet blanket on it. Although we've already blamed Justin for that. But my priority, I guess, is to make sure that while acceleration goes in, that the overall sort of readability and clarity and cleanliness of the OVS code is maintained. I think that we have some quality software there, and I want to make sure that the software paths still make a lot of sense. And on the other hand, what you were saying about 18-month compile times resonates a bit. I remember talking to Pat Gelsinger, the CEO of VMware, and it's notable because it's, I think, the only time I've talked to Pat Gelsinger. Telling him about some OVS acceleration that I told him would probably go in about 6 months, and he listened to me, and then Pat was one of the managers on, I think it was the Pentium 3. Anyway, he listened to me, and then he looked at me and he said, 6 months, basically get real. Tell me 18 months. And I think that's my whole spiel. So.
Okay, thanks, panelists, for opening statements. This was good. What we want to do is, as I said, there are a bunch of questions here. These are samples, but I want to open it up to audience, what they want to ask, and you can have directed question to specific panelists, a general question, and we will figure out a way to answer it. And I want to have a live discussion now. Maybe Justin will start with you.
I'll continue with the wet blanket theme. So I agree now we are starting to move to starting to be able to do connection tracking, which was my big concern for a long time. Now we're moving even further up the stack. So now we're starting to see L7 services. Is there a plan then to be able to accelerate that? Now I know OVS also doesn't support L7 services, but we have the ability to, for example, forward the packets to some other local processing that is done to do DPI, for example. Is there a plan for, the whole point of getting to 100 gig is that we want to completely bypass the host processor. Is there a way that we can then continue to get those accelerations, because we have to maintain them in the NIC in order to do those?
I'll just quickly. So goes back to my comment of as software features are evolving, we are not really integrated with the hardware, and that's why some of the partial offload, the software pipeline, has to be in a way that if hardware cannot support everything, it still allows you to offload partial part of it and still provide all these features. Other thing is we should definitely look at this L7 services, because we are now talking about connection tracking. This is the chicken and egg, and you are absolutely right. We will never get there if we don't work tightly on this. So on this one, definitely we should work together to see what kind of capabilities are out there and what can be accelerated.
So I think you're referring also to to regex, right? This is something that in DPDK there is a work that we started with a Cavium and Intel or on working on a regex device in software. Malmos has also the capability to offload this regex section in Bluefield 2, so it's coming this year. So we definitely have plans to offload this activity.
Okay. Yeah.
I have one question on IPSec. What I understand, especially in the edge deployments across the nodes, people tend to use IPSec, Genevieve over IPSec or VXLAN over IPSec, whatever the case may be. So I'm trying to understand in the SmartNIC OvS acceleration use cases, are you also offloading or thinking of offloading IPSec also? Or if you don't offload IPSec, I guess all the packets have to come to software. So what is your thought and where are we going?
Thanks.
I want to endorse what your question is. It's definitely going to be another challenge that we'll have to solve. We have our friends at Wall Street who are already asking for packets to be secure or encrypted. Right now, you need an IPSec offload card and an OvS offload card. So that's 2 cards. It's good for the NIC vendors. They sell 2 cards. But there's 2 hops also, and then the latency. And so all of that factors in. So what is the solution? I'm not a hardware vendor, but just my perspective is that there are different kinds of SmartNICs. There are SmartNICs which are silicon baked, meaning the function is baked in silicon. And then there are other SmartNICs like Bluefield and others which have a gigantic ARM core or hundreds of ARM cores on that. So for multifunction offload, and Broadcom has one also, Stingray. So many others have it. So I think for multifunction offload, that might be an avenue where you run a function, like you can do it on software, but the ARM assists with that software. So the main motherboard is still not taxed. So you can do IPSec encrypt on the ARM core and let's say OvS encrypt decrypt plus VXLAN. So for multifunction, I think there is a big possibility with that, and we are working in that space as well. So that's my perspective and lower hanging fruit compared to putting it all into silicon. And once it's proven with ARM and it's working and we have deployments, then most probably the hardware vendors can think about baking it into silicon.
So from my perspective, I agree with what you said, and that there's different types of silicon that could do different things. In the case of the metronome, we can do this in the silicon. We happen to have it. But I actually think this is largely a software problem to define what exactly this feature is and how it is presented to users. So the crypto part itself is fairly obvious. I mean, you encrypt the packets when they go in and you decrypt them sorry, other way around. But we have to define things like key management and what the associations are between the relationship of the security associations and the flows and so on. I think that's the first step. We have to cross that bridge before we can assess how to offload it. And as I mentioned in my introduction, if we can think about all of these, we can fit all these things in our heads at the same time, then we should be able to come up with a pretty good solution, I believe.
So just to comment on that, but the first time I think I attended the conference, I gave a presentation on implementing IPSec in software for OvS DPDK. At the time, just to echo what Simon has said, the data plane wasn't much of a challenge. It was actually all the control plane aspect became very invasive to OvS. So I think the feedback from that was that we kind of put that work on hold from the software implementation side in OvS, but that work is kind of carrying on DPDK now where they're trying to implement an actual just IPSec library for software completely. So that may help in the future as well, just from a software perspective, something we could review there.
I think I agree. So what is missing is the integration of IPSec with OvS kernel, and also for DPDK, it's a bigger gap because we don't have IPSec on DPDK, right? But in terms of kernel, by the way, IPSec is something that we can offload. We are working with it's work in progress also in my team. We are doing in kernel IPSec stack. We are offloading it for not to ARM on for the NIC connecting 6DX support IPSec. But we definitely need to think about as a community how we doing it together. IPSec and OvS currently it's not that is working.
Yeah, I mostly agree with all the stuff that's being said there. So if you want to really think about this from the OVS standpoint, we want to think about some of this kind of security function as how can that be in the OVS pipeline. Maybe we think about encrypt and decrypt as an action. I also want to leave a thought that when you get to higher layer like TLS, there are also TLS offload kind of solution out there. Integrating those kind of functionality in OVS, we really need to think it through because now we are not talking about per packet level. We are talking about at the message level.
Hi. So we've had a lot of technical discussion here. I wanted to change gears a little bit and ask about what you see are the biggest problems in deployment. So there's a lot of what needs to be done, and of course it's coming from deployment challenges, but not every deployment challenge is being addressed. So I was hoping you could sort of widen our view of what deployment challenges your customers are looking at. And since the panel is made up of folks looking at different layers of deployment, I expect your customers, like Red Hat customers, are different. And so just go ahead and give me a good idea if possible.
So the question she had was, we talked about all the technical stuff in terms of the stack and OVS. What are the deployment challenges, if I summarize, that you guys are seeing from your angle where everybody's sitting? So
I think the presentation that was given yesterday about exploring deploying 100G was a good opener to this topic. There's lots of problems. So some of the problems are things like a uniformity between using the vendors, different NICs from different vendors. People want to be able to select different solutions and have them largely work the same way. To some extent, that's already there, but to some extent, it's not. Another aspect is things like debuggability, which has been mentioned several times already, to be able to understand, for example, which flows are offloaded and which flows are not and why, to be able to sort of probe the system. And this ties into things like telemetry, to be able to observe the behavior of the network as it's running. And I don't want to talk forever on this, but a third area which springs to mind is things like field updates. If we have software and we update it in the field, that's of course a difficult challenge, but it's also perhaps largely solved. But for hardware in the field, if we think about a data center where there's lots of equipment and it's centralized, that's sort of one type of problem. But a different type of problem is where you have hardware out in the field, maybe some kind of remote point of presence, and there's very little hardware there. And you want to be able to field upgrade it. Say, for example, these smart NICs can be very complex, and because they run software have bugs, you may want to update that. But you want to be able to do so without losing connectivity, because otherwise you have to send someone out to fix. So these kind of issues, these are the kind of things we're seeing.
Thank you. So thanks for the question. I think that is a big challenge. What I tell my even people in Red Hat and NIC vendors and others is, imagine there is no command line. Okay, so what does that mean? So if somebody is deploying, if somebody has a niche feature that is just awesome, but requires a 500 character command line to turn it on. Those days are gone because now people are deploying it through OpenStack or OpenShift, and there is no command line. It's just like generic commands that come down. So even in RHEL, there are like, I don't know, 1,100 people who work, 900 people work on RHEL, and 900 of, like 800 of them use command line all the time. So even for RHEL engineers, the mindset has to be shifted that, look, you have to think about how this will be deployed from the cloud, meaning OpenStack, OpenShift, higher level. So imagine the NOC, like Network Operating Center, where people are moving icons to deploy and empty a node and add workloads, etc. So simple things like PTP, SCTP, old-time protocols to get them activated on the NIC is becoming a problem because of the deployment, plus the debuggability, plus all of that, what Simon mentioned. So it has to be thought through the cloud deployment angle. And that becomes an Achilles heels a lot of time. We had a conversation with one of the NIC vendors where for each node, a table had to be uploaded. And that right there is a showstopper because we're talking at the scale of thousands of nodes for 5G deployments, like hundreds of thousands of nodes. If each one needs a custom table, and each of those custom tables, even if it takes 10 seconds, that's a lot of seconds. And that just is a showstopper. So as a community, as with so many of my esteemed colleagues from the NIC vendor perspective, please just tell everybody there is no command line. We have to think about from a higher level going down.
No, so I was just going to add from where we stand, this tools integration, and then with the frameworks that people are using, that has been one of the big deployment challenge because as a user, you don't want to know what's in the hardware. That's really low state for you. Also, other related thing there is administrator and operators, they really get annoyed when you give them this 30-page document describing all these 20 steps, how you have to enable offload. They want those things to be transparent, automated. That's one of the challenge also we have seen that even with all this framework you have described, make sure this flag is set and this and that, that just doesn't work from the seamless deployment standpoint.
So the people are coming to us and saying, its simplicity is key. Even if we miss out a lot of good features, make it simple to deploy and we will go with that solution. Even if it covers 40% of what they are asking. If it's simpler to deploy, we will go with that 40% as opposed to having 100%, which is just a pain in the neck to deploy.
Thank you. I'd like to talk a little bit about Simon's point of taking the holistic approach and the hardware having a more high-level view of what the users are trying to achieve. What do people think about this? Is it worth doing? And if yes, how can we move forward in that direction?
I think that's a question directed to you, Simon.
Well, obviously, I think it's a good idea. So what I'm specifically getting at is perhaps, I mean, my visibility of the stack sort of extends from OpenStack down to the hardware. Perhaps there are higher layers there. They're out of my visibility. So I think that sometimes the way OpenStack, and I'm not picking on them, it's just that I am familiar with it, deploys things is that they seek to use the existing technology, and that's great. And they sometimes come up with very creative ways to pull features out of what is there, and perhaps at the cost of extra complexity and extra actually performance impact, even in the software case. So, for example, say you're in a situation where you want to share, say, some combination of overlay and underlay access to a particular VM or something. Now, it turns out that in that particular case, the way OpenStack models this it becomes very difficult to handle at the hardware level. So perhaps rather than try and work with that, it would be better to go back to OpenStack in these kind of cases and say, what is a better way to solve the problem that you're trying to solve? what is a better way to give access to these different networks and to model that in a way that is cleaner throughout the stack.
Okay, so we are out of time here, and we have break. So I think those who have questions, you can come here and talk to people here. But I want to thank all the panelists here. This was really good discussion, and this is the kind of thing we want to discuss in the open forum. What are the issues? What are the challenges? Different perspectives. So thanks, everyone.